we have generated this as being our technique for computing the surface area of a surface of revolution if we're revolving some curve about the x-axis. Y is the radius. Where I have two versions for ds, they're given down here. And exactly the same idea. I think if you're rotating about the y-axis, it's just now nothing changes other than the fact that your radius is x, and your bounds integration are going to be y values, not x values, unless you integrate respect to x. So I'll illustrate that in just a moment. So technically speaking, you may see two formulas here, but since ds has two versions, you're really seeing four different formulas. I want you to consider the graph of this equation. We know what it looks like. Over the interval from 1 to 2. And I want to compute, or at least set up an integral that would determine the area of the surface of revolution obtained by revolving this curve right here about the x-axis. When I'm done, I'll revolve about the y-axis. Two completely different shapes, don't you agree? About the x-axis, I get this cup. No hole in the middle. That was bad. But if I revolved about the y-axis, I think the surface looks completely different. So, first things first. About the x-axis. If I integrate with respect to x, that means this y is going to have to change its looks. And so if I choose to rewrite this involving the square root of 1 plus this, I am indeed integrating with respect to x. So the y is going to have to change its looks. It looks like a natural log of x. Bounds integration from 1 to 2. And now let me go ahead and put within that radicand another name for dy dx. So I hope you will forgive me and allow me with this last example just to set up my integrals so you can see what they look like, but not actually finish evaluating. Now, here's one approach of generating an integral. To compute the surface, or excuse me, to compute the area of the surface of revolution when I revolve this piece of curve about the x-axis. As an alternative, but still revolving about the x-axis, I might have integrated respect to y. In which case, I have this. But wouldn't that look like this? Now, solving for x in terms of y, x equals e to the y, whose derivative is still e to the y. I'll square it. I'll integrate respect to y. I think my integral looks completely different. My bounds also change. But again, I won't evaluate the integrals or even try. Now, if I want to take this piece of that curve and rotate it about the y-axis to generate a surface of revolution, then I think the radius becomes x. And I have my choice of what version of ds I choose. If I choose this version, then this factor simply doesn't change. It's already in the name of my variable integration. I suppose I should replace this with this. However, if I chose to integrate with respect to y instead, then I think this is what happens. Number one, This x has to have its name in terms of y, so I look at that relationship and I replace x with its alternative name in the variable y. My bounds of integration change. And of course, I need to compute the derivative for x with respect to y. There's a set of my integral that'll answer the same question. Both these look very different, but they will evaluate the same number if you're able to evaluate those integrals.